Hello and welcome back to development of the Feersum scheme compiler. Right, so in the last episode we went over adding diagnostics to the syntax tree so that we could parse syntax and try and get as many different errors as possible. So we support some kinds of levels of like fallible parsing, where if we encounter an error, we try and stub out an expression and then carry on parsing. So the plan for today is to move on from there and look at adding position information to the syntax tree that we produce so that we can emit diagnostics from the binder as well as the parser. The idea being that if we get a problem when we're trying to bind a syntax tree, we should be able to do something a bit more interesting than just throw an exception. So let's have a look at what the state is from last time. Most of the work was here in the parser and syntax module. We added this new type, diagnostic, which is a position and a message. So position is actually the position type from fparsec itself, the parser combinator library that I'm using here. And then we have state for our parser now. Our state contains a list of the diagnostics that we're buffering up. And then we have a few parser combinators which allow us to deal with errors. So the expect parser expects a given parser to pass, and if it doesn't, we emit a given message. So the way that works is it runs the parser, and if the parser status was a failure, then we emit the message and we return a none. So this turns the result type of the parser from T into optional T. And then we have this skip unrecognized parser, which we use for the case where more graceful fallible parsing has failed, and we just give up and skip the character we're looking at and then carry on trying to parse. And that's used right at the root where we do parse, where we do the parse, we do many parse form or skip unrecognized. And this means that every time we encounter an error, we'll end up with an error node in our syntax tree, and both skip unrecognized and expect will also emit a diagnostic. So with that, we should be able to handle far more pieces of input source which contain some level of error, and we should emit a few diagnostics. But to be able to emit diagnostics from our binder, at the moment our binder gets a syntax tree, and if we look at the syntax, the main bind method calls, where is it? Binding context. Bind takes the scope and the node to bind and returns a bound expression. And then the compiler in compile will call the binder, and then it will call emit. And this ends up eventually returning a list of diagnostics if you call compile file. So the way this should work is that bind and emit should also be able to return diagnostics, which they can't at the moment, partly because they don't really have any position information to be able to provide to those diagnostics. So that's where we're going to start today. So the syntax tree is made up of these AST nodes. So what I'm going to do is I'm going to introduce a new type, which is going to be for well, we're going to rename the existing type to AST node kind. So AST node kind is the different types of syntax node that we can have. So it's recursive here in that we can have a list of forms or a list of so if you have like a sequence as you would get in the body of a lambda, or if we have a form which is where you've got a bracket and then a piece of source text. Let's go try and find an example. If you have a look in the spec, so each one of these bracketed expressions is a form. So this is a form here with an A, and then this whole thing is a form, and then this whole application is a form. So if we have a look at the syntax, you have that's one way you can recurse, or the other one is if you have a sequence which is used at the root to hold our whole program, and then also in the body of a lambda when you define it, we have a sequence there. So what I'm going to do is I'm going to reintroduce the AST node type, which is this time going to be made up of a kind, which is an AST node kind, and a position, maybe span, which I've not decided what. Span will be a span. Text span. A text span is a span. It's a position, a pair of positions, effectively. Or this could be a text location, which could be a span or a position. We'll use this text location type as the argument for our diagnostic, and if we've got a span, when we if we've got a span, we should just return the starts, and if we've got a point, we will just return that. What's wrong here? I think that should. This might want to move into text location in the future. Point in the source text. So a node is a text location and a kind. We can't use kind yet because the type is mutually recursive. Yeah. How do you do a recursive type in F#? Mutually recursive types. I think we just do and. There we go. But I think we need to indent this, maybe? And it's, yeah, it's just an and, okay. Let's see what we've broken. Stream.position, we want emit should probably pack up the position as a text location point. And that's not how you do. And when we have an error, we also need this to be a text location point. And now we will have broken the interpreter because the interpreter is expecting. Oh no, a second, the interpreter shouldn't be broken, it should just be the binder that's broken. So the binder gets the syntax node, it calls binding context for that node. Right. So some of these will be broken now. Sequence and form. So bind sequence, it's got these both should recurse back to AST nodes. So each recursive node is going to have its own position information. Right, so the things that we should have broken, formals. Just going to try building it. So parser is going to struggle because we aren't actually producing AST nodes anywhere. So form is an AST node. Where are we going wrong here? I would expect that bind form which has now got a list of AST nodes, and bind ident should be the places that are broken. So a form has this is awkward. Let's see whether or not I can do the bind sequence one first, because hopefully that'll be a little bit easier. Bind sequence, where is it? So that just maps binding context, which takes an AST node and returns a bound expression. So that's fine. It is just the form and formals for some reason. I'm not sure why formals is bind formals. It is because this is a AST node kind. So the problem all comes down to this match expression in bind form. So this is supposed to be, the body of form is supposed to be a list of AST nodes. So I'm just going to type annotation for that. and then hopefully everything else should follow through from that. So to match this, we actually need it to be an AST node where kind is yeah, kind is ident. Can I do that? The pattern discriminator AST node is not defined. So what does a record pattern look like? A record pattern looks just like that. It doesn't have the type on the front. Pattern does not have to reference all fields. Good, because this one doesn't. So every time we've got an AST node kind here, we need to do let's try and do this with multiple cursors. Yep. So for each one of these, we want to kind equals can we rely on this working? No. Alright, that seems to work a lot better. And then in here where we're matching against specific list expressions, we need to do the same thing. An ident and a value. This is tedious. The form is going to need to take another recursive pattern. Great. This isn't actually turning out to be as bad as I feared it was going to be. That's a list of AST bound formals list. Hopefully the type should all come out in the wash when this gets sorted. List of AST node, that is a list of AST nodes. So why? But inside bind formals list ends up conflicting. Then here we want the kind again. Got the formals broken there. I think that's an old error. Then I think we've got a problem in bind formals. So in bind formals, we call bind formals list. And this is going to do some matching. On the formals, which I think is to do with this pattern here. So if the kind is an ident, actually we could just do formal.kind. I should make the formals list stuff a lot happier. And then what else we got? Compile. Parse file returns an AST node kind, but it really shouldn't. That's because parse really should be a parser of AST nodes. So this needs to be so now we're now at the point where the parser has got a whole bunch of parser has got a whole bunch of errors that are caused by us not returning the right thing. So so the first thing I guess we want to do is to have a node kind for these errors. Which is going to have kind of error and the position is going to be text position. Don't know. I wonder if we want an error location as well, but maybe not. Can I just create a position? So a position needs a stream name, an index, a line, and a column. So we'll just set those all to 0. And they all need to be in 64s. So we're all good. Then we should be passing the error case correctly. So unpack returns an AST node. So pass form needs to basically every single place where we reference one of these, we need to put a location on them. So where do we construct an ident? Here. So this is the identifier. To put a position on it, we want to do something like this, where we take either of those, but then we do get position, which returns the current state of the parser, and then we can just and then in the ident we would then make this a function that does a first like start and then params and then end. We would do new where the kind was ident with I. If I can write this once, hopefully I can create a parser combinator that abstracts away actually getting the position information and then creating a new parser. And then location is going to be span start and end. What is wrong here? That's not how you do a function. That's expecting a position and then a string. That's because of the way that these get paired up. That actually compiles. Right. So what you'd want is we've got let's in or atom the atom parser would be this, which is parsing the actual value of the atom itself, so like the identifier or the character or whatever, and then the atom constructor is ident. Let's move this pipe onto the new line. And then I think this can be extracted as something like a spanned atom or something. Then we can go through, and in the case of parse number, this becomes spanned atom p float number. Unescaped cat, that's fine. Hex scalar value. We're still not creating any instances of these yet. This is a literal, so we say this is a spanned atom lit. This is the ident, which is spanned atom of this ident. Parse character. That does. Yeah, that is a skip. That's spanned atom again of that character. Bool, parse bool. starting to wonder whether or not it might be nicer to have the parser and the constructor the other way around. Because if we did it the other way around, if we do spanned atom, atom constructor, atom parser, and then do this as like number p float, and here we do str and lit. We can actually change this to be something like between that, pipe it to spanned atom, which makes the whole thing look a lot nicer. And here ident bool becomes spanned atom. And I think I can get rid of those brackets now. Dot. So this doesn't produce a value, but I think it's actually a unit value. So I think we might still be able to do spanned atom dot. Nope. What is this? Do I need to do the if I produce a unit value, is that still gonna? Spanned atom of kind. How is that going to work? Spanned atom of kind. We still need a parser. It's just going to do spanned atom. Character, what's wrong with character? It's a parser of AST node. So here we've got the form. I think this could actually just be spanned node of kind and spanned node. Because it looks like we don't actually do anything interesting. Hello there, Hitsman 10122. What's up? I have not been paying attention to chat. I'm just refactoring the parser part of my compiler so that we can put a text location, which is our way of knowing what position a diagnostic should appear, onto our AST node type, which meant that the AST node has changed from just a plain old enum or whatever these things are called into a record. So now I've got to refactor the parser to actually produce nodes with position information on them. So this wants to be spanned node form. That makes an application kind of work. And then here want a spanned node of sequence. I'm not sure how many of these errors are real and how many of them are just fake old errors. It's fake errors. Why is unpack unhappy? Unpack says takes a parse result of AST node and produces an AST node diagnostics list. And this says it should take a return AST node, but we want these to return AST node kind. That's just a leftover from the rename earlier, I think. REPL. File takes an AST node. And evaluator is an AST node kind to unit. Why? No. REPL takes an evaluator. Why is that? Because read returns an AST node kind. Why does read return an AST node kind? Because it claims to. But it shouldn't. It should return an AST node. Because that is an AST node. How close are we now? That's relating to the previous error. Binder 266. Bind formals. Formals is an AST node, and it's expecting an AST node kind. Why? Because we don't do that. Is this the one error? Our cat has just been injected into my room. And is now escaping. There is problems in the tests. Right. So a whole bunch of these tests we can make read single here return the kind. So if we get a sequence of expressions, so read expression returns an AST node. So if the kind is a sequence, then we can return that single expression, but what we really want is that.kind. If there is a single expression, we'll return the kind, and then we're returning an AST node kind, and then some of these should start just passing. It's like Boolean false. Read many. Yep. So read many. I want that to be. We kind of want a way to ignore the position information here. Oh no, I'm going to comment that out and leave it to do. Not quite. Because when we get super deeply nested things, it's going to be really awkward to actually create all the different nodes with all the different positions. But we're doing the same thing here as well, in that we're building these syntax trees. So I guess we need a better way. The evaluator, this gets passed in. See, the trouble here is that the evaluator is being inferred to have the type kind to string, but really it should be AST node to string. Because these are all AST node to strings. Does the syntax tests at least compile now? Because if that does, what we can do is just not compile the evaluator test for the time being. So we get it compiling, we can try running it and seeing what we get. Well, it compiles. And it still kind of works. Define foo AB. That looks good. I'd be interested to find out what the tree looks like. So let's go have a look at the REPL. So the evaluator is going to be eval. So if we just run that same syntax tree again, what do we end up with as our syntax tree? So the kind is a sequence, the location spans line 1, column 1 to line 1, column 39. And we have 2 nodes. The first one goes from line 1. I think I'm going to dump this in the debug console. That's a lot nicer to read. Yeah. Define, which goes from column 2 to 8. Then the form for the it's nice. So we've got lots of position information in the syntax tree now. So kind of works is the best kind of working. Challenge now is to try and make those unit tests actually work rather than just kind of working. So what I'm going to do is I'm going to create a new branch and start committing some of this stuff. So So in the binder, we're matching on kind all over the place. I think the binder changes are pretty much done. Syntax, we've added the text location. We've got this diagnostic. What I'm going to do is I'm going to move that so that, because up here in our diagnostic we're getting the position, but we can actually turn that into actual member on the type. So I think we would have member start would be, and then we'll have a corresponding end method as well, and then we can make this down here we get a location and we say position is the location start, and all good. I should try that out just to see that it does render the correct thing. Putting some syntax errors into our syntax tree. Line 1, yeah. Could I do? Something's got syntax errors in different places. Not quite. Not bad. So that's working. I don't really know what happens in other compilers when you've got, so if you've got a location, does it print both the start and the end of the location? Maybe. But for us, for this, just printing the start is fine. So that is the change to the parser, and we've got our error node. This, I guess, will, if we come up with some kind of better way of creating or stubbing out nodes, we could replace that, because we kind of need a way of stubbing out or building syntax trees with position information to be able to make the unit tests work. And that, I don't think we want. We can commit that syntax test stuff and syntax. So what is this going to be? Add position to syntax. Introduce a location type and use that in the syntax tree. Each node has a location and a kind. Update the binder and update the binder accordingly. So let's go and make the syntax tests work first then. Let's try running them just to make sure that even with everything commented out, it still works. Failures. Yes, all of the snapshot tests have failed because all of our snapshots now have position information in them. So let's do the update snapshots. Task, update snapshots. And then we can diff that and work out if everything looks acceptable. Not hugely worried. So we've got a bunch of kinds all over the place, and we've got locations. This repeating stream name isn't great. I wonder if, I think in the library that I'm using that you can get it to sanitize the input. So let's have a look if we can do that. So that's in the spec tests. Should match, wait for exit. So parse file, snapshot ID, child snapshot name, snapshot directory, class name, method name, child snapshot name. That's fine. Should match snapshots. Just trying to get the documentation for this thing. Here we go. So basics, child snapshots, inline snapshots, that's it. Great. Well, I'll add them all as now for now. I think the solution to that is going to be to create a custom serializer for the position. So if it's a location, we can serialize it as either a single, I mean, because like location doesn't need to have all of this information here. You could have a JSON serialized form of it, which was just a string or something like that, that made it a lot nicer. But that's not an issue for right now. So syntax tests. Let's just bite the bullet here and make all of these. So if we say that's the kind, the plan I'm gonna have here is update the position to have some kind of like special value for this position doesn't really exist. And then we can just use that instead of the real position. Or how about, this is a cunning plan, how about we have in syntax, we've got these two recursive types. What we could do is we could make AST node kind a generic type. And then we can have, instead of having we make this an AST node kind of type AST node. But we can then strip the position from the node. So in the syntax test, we would say this is an AST node and that is an AST node. If it is a form, we return, we're going to have a fallback case of just, in all other cases, return end.kind. List.map. So the plan here is that we can go over the syntax tree and just transform it into a type of syntax tree that doesn't contain any position information. And what is this upset about? Expecting types A and AST node kind cannot be unified. It's a shame, really. What's this one complaining about? Can I write type node no position Okay. I think I see the issue here. The problem here is that we can't really actually name that type properly because it's really infinitely recursive. How do you do that then? So we can have like a plain type that recurses. Yeah, I don't know what to do there. Could we say it is a node n, or we can? I don't know whether or not this is going to help. This at least strips the position off it. Gonna have to name each one of the things in the AST node and repack them. So we've got form and sequence done. Maybe. Error. Well, maybe we could do node and kind. AST node, I guess. That's broken a lot more, which is a positive. Hi, yes, Sir Jonsson. Yeah, there's not that many people writing F# on Twitch, that is true. I started writing F# because I don't think I really had a very good reason. I think it was a case of I should write another compiler. What language should I do it in? F# seems interesting because I know C# from my job and I like functional programming and it's actually quite nice. That refactor has definitely made things a lot worse, but why? Because I think read single at least can actually just do kind and then exactly one dot kind, so we can just get the value out of there. And then that should be, I think we just want to make these all A's. maybe. Yeah, these would have to be B's. The ident would have to be a B. A number would have to be a B. I'm not sure this is really making the situation any better, to be honest. Form is an A, the Boolean would be a B. And then the whole sequence is a B, I think. Oh, it's an A. Naming things for the win. So, does that work for some value of work? Haskell does seem unnecessarily extreme. I did have a go at learning Haskell, and it's quite alright, really. But I didn't really have anything to do with it, which is the main issue. What computer do you have? I'm just running this all on Mac OS. I've got Visual Studio Code, and I've got this plugin for it called Ionide, I think, which is, yeah. And my PC's streaming with OBS and running code and all the rest of it at the same time, and seems to be able to keep up. What has gone wrong here? The binder is struggling because we haven't told it. Does that need to be AST node kind AST node? Yeah, this isn't necessarily solved our problem. I think you can run VS Code and should be able to develop F# in either of those, on Windows or on Ubuntu. But if you spend more time in Windows, because gaming or whatever, yeah, you should also be able to use Visual Studio. I don't use Visual Studio, obviously, because I'm on a Mac, but you should just be able to install Visual Studio and get started using that. Personally, I use VS Code because it's lighter, and I feel that, yeah, I prefer a lighter weight editor than Visual Studio, but I know a lot of people prefer Visual Studio. And you should be able to get that one for free. There's like a community edition or whatever. Anyway, What's going on in the binder? Has it actually just magically started working? Yeah. So I have no idea what was wrong. And the unit tests pass. So I think I'm gonna call it a day soon. I find when you're learning, you're saying you haven't learned F# yet because you're not quite sure what you'd build with it. And I find the same. I usually learn languages better when I actually have something to do. Obviously I build programming languages, that's what I do. Yeah. So I'll often find myself tinkering in a new language, building yet another new language. But if your thing's web dev, maybe try web dev or come up with something. Why did I choose the CLR as a target for the compiler? I chose the CLR because I've built compilers and interpreters before that worked. So like tree walk interpreters, I've built compilers that targeted bytecode and like built my own VM and things like that. And I built compilers that used LLVM and to emit native code. But I use .NET at work, and I was just interested in being able to emit something that worked for the .NET ecosystem, because there's a whole lot of stuff that's available. And if you could build the idea is that Scheme is a language that you can compile because it has syntactic scope, which means that you know when you're running the compiler, you know where each one of those identifiers should map to. So it should be possible to compile it to machine code. So it should, in theory, be possible to compile it to .NET IL. So, well, I think I've proven that it is possible. And if you could have a way in the language, if you could come up with a way of calling, like some kind of FFI way of calling into other .NET stuff, then that would make it quite powerful. But yeah, just interested in seeing what it's like to build a compiler that uses monosessel as the backend. Nothing other than mild curiosity, really. So, got our syntax changes. Still not all the tests working. Let's publish that branch. So the eval tests, these are going to be interesting because this is going the other way around. We're not trying to build up, we're not trying to compare equality between something that we've we're not trying to compare for equality where the thing that we're trying to build up here, that this AST node is the thing that we need to compare to. It's got to be the input for the interpreter or the compiler or whatever. So it needs to be like a real AST node. But it doesn't need to have real position information. So what we really need is just a function that takes a node and returns an AST node. So what we're going to do is just set the kind to be the node, and then the location can be some kind of dummy location. And it's going to be a point, and these all need to be longs. There's a few things that as a C#, well, coming from C#, I've always found myself tripping up on. And the fact that numeric literals don't just magically change from one type to another is definitely one of them. That's going to be fparsec.position. Okay, and so now we've got n, we can just basically we'll just pipe it through n for everything. So like the ident needs to be through n, and then form, and then the ident. Actually, I'm going to copy and paste this because I feel like I'm going to be typing it quite a lot. And then the number, and then the form as a whole, and then that form. Yep. So ident number. This is exciting. One last failure. And on that. Not really sure what the best solution to this is yet. See, one thing that I've learned about is catamorphisms, which is kind of like a way of mapping a given set of functions over a type like our syntax node. So we could use that to transform syntax nodes from one type to another. And so that we have our AST node the problem is that this and this. I need to do some reading and work out whether or not there's a way around that. I think you can pass a type into itself in C#. So it should be possible to do the same thing in F#. It's called like the curiously recurring template pattern where you pass a class in to the thing it's inheriting from. But yes, you're passing it into what it inherits from. So maybe we need some kind of, and that's how we're able to do it with things like AST node can pass itself in, and the node with no location can pass itself in. Interesting. This is looking a lot more like it might actually compile. I think I might have gone too far. Oh no, I'm missing one here. Right, let's run these tests. Fingers crossed. Off by 4. Can it be converted to... Oh, right, so that's what we saw before, where we've got some problems even in other cases where, yeah, these things. That one is also expecting an AST node kind. See, how can you write that? Oh, well, I mean, it's just fabricated the type, because this tree doesn't recurse forever. The compiler can come up with a type that says, oh, it's an AST node of type, AST node of type, and then some other thing I'm not going to tell you about. Is that it? Didn't feel like 4 hours. But some of these are, yeah, these are theories. Okay, right, that is 4 hours. Success. Fix up the evaluation tests. So I'm still not 100% happy with that, but if it works, it works. I'm expecting that there's probably a cleaner way of doing this so that we can build up these trees. I mean, this isn't the worst with all this piping it to N, but it is a bit fiddly. And it would be nice to be able to. It would be nice to be able to make a tree up. And then add all of the fabricated position onto it. So it might be that I work in the parser and have like a way of mapping between AST node kind T and some kind of like recursive type that, yeah, we'll see how it goes. Anyway, so thanks for watching, and I hope you enjoyed this. I've definitely enjoyed getting this working. Hopefully with the position information in the syntax tree, we should be able to start emitting errors from binder in the next stream, rather than doing what we do at the moment, which is just panic if we encounter anything that we're not expecting. So that'll help in two ways. One is that if you do something like reference a symbol that's not defined or something, we will be able to move on and try and bind the rest of the tree so that we can tell you about other mistakes that you've made, because that's definitely a more user-friendly solution. But also we'll be able to actually tell you when you did make that error, where you made it, so that you don't have to like go and dig through tons of lines of code to try and work out where you've actually made your program mistake. But I'm going to wrap it up now for today. So thanks for watching, and I'll see you next time.